Okay. All right. Great. Welcome everyone, and thank you for joining GEWEX Global Flood Crosscutting Project March meeting. We are grateful for your continued support with our initiative. Um, those of you who are new, I just want to let you know that we have this monthly meeting every month on the first Friday of each month at 9 a.m. Eastern US time. So we have great keynote speaker, great discussion about different aspects of flooding research. So you can see a list of previous and future speaker here, and you can see how you can fit your schedule to attend those talks. So a little bit about this flood cross-cutting project. Uh, Dr. Josh Randy, along with Dr. Conrad Vasco and myself, chairing this initiative for GEWEX Global Hydrology Panel. And the focus is to bring different kind of researcher and scientists across the globe to understand the perspective of their flood-related research, and then we synthesize these studies and then work on a final report as a science report and submit it to GeoX. So all of you who are going to present or participating in this program, you will get an invitation to contribute to the final report, hopefully very soon, so that we can work together and address all aspects of flooding issue across the globe as part of this initiative. So we also want to let you know that we submitted our proposal. Some of you are new, and then our proposal got approved by the GeoX GHP panel. So that's the reason we started this initiative from last year. And also there is a Google Doc where you guys can, I know many of you are Sims from South America, which is great. You guys can add your publication, your research, or any kind of papers that you have related to flooding to this Google Doc so that we can use your information in the when we write the final report for GeoX. So please feel free to add your publication and your thought in this Google Doc so that we can use it for final report. So today we have a great uh, keynote speaker from South America. Very interesting area to hear research related to flooding and kind of climate extreme in that region. We have Dr. Juan um, Salazar, am I correct, from the University of the Antioquia from Colombia. I'm sorry if I am not. I didn't say
That's fine.
yes. So very glad that you accept our invitation, Juan, and very excited to hear about your research. So the stage is yours.
Okay, thank you very much for inviting me. I'm very happy to be here. I'm Juan Salazar from the University of Antioquia in Medellin, in Colombia. And I will tell you a story about the Aburrá River Valley. Here we have a Medellin city and other Colombian cities, and first I want you to know several things about this place. The first one is that there's a lot of people living here. About 4 million people lives in this valley, which results in a very densely populated area with more than 6,000 people living per square kilometer, I mean. So it's a densely populated valley, first thing. Second thing, like I would say almost every Latin American city, this is not fully planned. Uh, this is partially planned. So we have parts of the cities that are well planned, well designed, I mean, and there are parts of the city that are, I would say, like creative. So part of our city was self-built, and this is part of our context. The third thing I want you to know is that this is a very steep and a narrow valley. Depending on the scale, you could say that this is like a crack in the ground, as you can see in this model. So there's a lot of people living right here. So Medellin city is around this place. You can see my pointer, right? Can anyone confirm? Yes?
Yes.
Yes.
Okay. Okay. Thank you. So it's about 4 million people living in this crack in the ground. Another thing is that it rains a lot, different types of rain. Sometimes it's concentrated like this one in the picture, sometimes it's like long duration rainfall distributed over the territory, but generally it rains a lot. So you can imagine now that this is like an ideal place for having floods, and that's true. And another important aspect is that this city was built around the river, around the Aburrá River, which is sometimes called the Medellin River as well. And during the first half of the 20th century, there was an idea that dominated the development of this place. The idea was channel to industrialize. So politicians at that time and engineers thought that uh, building channels for everything was a good idea, and they did that a lot. So the city we have today is uh, largely the result of that idea. So we have a channel for the main river, and we have a lot of channels flowing into this river. Some of them are even behind the city, and many people don't even remember the channel. So there's a lot of people living just above all channels, and they simply forgot the stream behind them. So uh, maybe it was a good idea. They implemented this during that time, but one thing here is that all those channels were designed, were conceived, and were built with no information about climate change. They didn't have information about this. So they did their math for a different climate. And that's one of the key points of my talk. I will say that there was a river and there was a climate which is very different from what we have now. In this picture, you can see the old river flowing. Okay, now at this very moment, I'm right here. So I'm over the old river. Of course, it is not flowing in this way nowadays. It's flowing through this channel that you can see here. This is the channel that was built, designed, and built during the first half of the 20th century. So there was a river, and today this is one of the aspect that influences our flood, flood risk today. So what we have now is like a new river in an old channel. This is a recent picture, and as you can see, the river is about to overflow. Engineers do not design channels to work like this. Engineers design channels to uh, uh, with the idea that this should be a very, very rare condition, an exceptional situation. So if you see the river like this once in your lifetime, maybe you don't see it twice. So if you see the river like this should be like a classic anecdote. So you could say in a party, okay, I once upon a time I saw the river about to overflow. It was 30 years ago. I have a picture. Let me show you. Okay, this should be like a rare anecdote, but it isn't because people in this valley are getting used to see the river like this several times, maybe several times during 1 year, maybe. Yeah, this is not rare for us these days. So to me, this is like the river telling us, okay, I'm not the river for which you design and build this channel. I need more space. This is a small channel for this big river. And yeah, we have many photos like this and videos like this one. I hope this works. Trying to make this. Okay. Yeah, you can see the river which is about to overflow. And there's a street here, plenty of people. And as I was saying, this is not normal. You don't design channels to behave like this often. Maybe in an exceptional situation, but not often. And that's a problem for us. That's challenging for us. And as a result of these dynamics, what we have is like a pulsation in the river. This is frequent. This is another day, and you can see the river just like going up. Here, I'm sorry. Okay. Here you can see the rainfall as seen by a radar. This is the rainfall behind that pulsation. This is the accumulated precipitation. This is the river level. And this is also a river level. And here you can see the pulsation as seen by a camera, right? So we have this, and this is occurring so often, more often that I would say is normal. And it has consequences, of course. So just this is the river, and this is our main system for transportation. This is the metro system in the city. And this type of holes have been occurring several times during the last years. And of course, there's a relationship between this pulsation and these holes. So people is worried about this, and not every people link the dots. Not every people here in the city find or understand a relationship between the river pulsation and these holes, but of course, there's a relationship. Uh, in engineering, we are used to do maths based, for instance, on the return period, and this is an old estimate of what would be the peak flow for a 100-year return period, right? This is in a report from a local authority. So this should be an exceptionally high peak flow. But what we have is that in recent years, maybe 15 years, we have had more than 60 events that in which the peak flow exceeded this number. So is this really a 100-year return period? And the answer is, I think it's obvious, it is not. The statistics of the river mm, have changed. The river is different and very different because, as you can see here, this peak flow is more than double the old estimation. So we have many things in this city built with numbers like this. Remember the old channels, the old, yeah, many infrastructure was built with numbers like this, but the reality has changed, and then we have a challenge here. So there was a climate. We had a climate, and we built this city for a climate that existed before, but uh, does not exist anymore. So the obvious question is what's gonna happen? What's gonna happen? And as you know, there are different scenarios for the future, and we want to know what's gonna happen for our city in any of these scenarios. And we have studied that. And to do that, we selected, for instance, a basin. This is our study basin for the results I will show you. About 20%, 25% of this basin is urbanized, densely populated. This is in Colombia, in northern South America, tropical South America, and here it is the Aburrá Valley. So this is the basin. And what we did is to look at the climate models from CEMIP 6, from the IPCC. I don't want to give all the details here, but these are just different models. These are different indexes related to heavy rainfall. These numbers here mean that most models agree that heavy rainfall will be heavier. So we use this information to transform and observe events. And this is the rainfall behind an event. I'm sorry, there's some Spanish here, but I couldn't translate everything. But this is the basin, and this is the moment where we had this peak flow in the river. And before this peak flow, we had this pattern of rainfall across the basin. So we take different events like this, and then we transform them according to the projections of climate models, and we get things like this. This gray line shows the accumulated rainfall during the event that caused that peak flow that I show you. And this orange and kind of green or blue line show the same event but exacerbated by climate change according to two different models. So there's a high uncertainty about the magnitude, but most models agree that heavy rainfall will be heavier. So the uncertainty about the sign of the change is lower. So then we take this rainfall, historic rainfall and projected rainfall, and using a hydrological model, produce peak flows. But before that, note that here we have 40 millimeters or 50 millimeters. Uh, 1 month ago, we had 84 millimeters in less than an hour, and this was part of the result. It was only in a small part of the basin, so this was not about the whole river. But in a small part of the basin, we received this rainfall, and this was the result. The river is just here on the left side. There's a small stream flowing behind these streets, and this was the result. So 1 month ago. So this is the projected peak flow. So the dots show measurements. The black line is like our simulation of the peak flow in the historical events. And these color lines show different projections according different models. So remember the number I showed you before, the 100 return period peak flow was about 300 cubic meters per second, and this is above 500. And due to climate change, we can go to these places, which some of them are even above 1,000, which is a tremendous discharge for this channel and this river. But climate change is not the whole story because this there was a city as well. We had this city, this valley, some decades ago, and now we have a city like this one. This used to be like a hotel, the nicest hotel in the city at that time, just in the countryside, but the city just swallowed the hotel. Madonna was here when she came to give a concert in the city. But the city swallowed the hotel, and the urban area has expanded towards the Hislop. So it's not only climate change. The city has been changing as well, and this has implications for flooding, of course. So we take the current urban area and did an exercise for projecting this urban area. Um, and these red areas you see here are like projected. So what we expect is that the urban area that currently covers about 25% of the basin will cover about 40% of the basin's area in the next 10 to 20 years, likely. Maybe, but we think this is very likely. And so we asked what would be the impact of this on flooding, and this is the result. These are the results I previously showed you. So the peak flows exacerbated by climate change, but if this combines with urban expansion to the right, these peak flows will be even higher as expected. This is not a surprise, of course, but one important thing here is that the average of the projection here, the average of the projection is around 1,000 uh, cubic meters per second, which is the more than three times the previously estimated 100 uh, return period peak flow. And this is for 40% urbanization. And since we are curious, we just uh, consider just as an idealization. We don't think this will happen, but we assess complete urbanization, and of course, the peak flows will be even higher, much higher. So what to do? Uh, We have been working with many people, with the local government on ideas about what to do, and all of the ideas can be summarized into simple ideas. I think one, we have to do two things. We cannot resolve climate change. We have very little influence on climate change, so we depend on industrialized and rich countries for that. So we have to adapt. And what we can do is are two things. We have to slow down the flow in the slopes, and we have to give more space not only to the main river but to all other rivers. So we have to maximize these two things: slowing down and giving more space. And we have to do it quickly because you know that climate change is advancing really quickly. And here we find like a bottleneck because these news are hard to process for politicians, for our leaders, I mean in the government. So there's a bottleneck because this sounds difficult, and it is difficult, but I used to say that things will change in one or another way. So things will change via decisions, and we want that to happen, or will change via disasters, because there's no alternative. Things will change and the city will change, and hopefully we'll do that in the best planned way. And there are good things happening, and I'm about to finish. One good thing is that the local government is aware of that. Uh, Many of the results I have shown you come from two projects uh, that we in the university developed thanks to the local government, to Alcaldía de Medellín, and they, for instance, support this early warning system for the city. This is an image that just at this moment, I think these clouds are just arriving to the city. This is the city, and these clouds are coming, and this image is almost real time. So we have these things, and we have the data, and this is thanks to the government. But it's not only the government. We have in the city the PICC. This is not the IPCC. This is the PICC. This is the Intern Neighborhood Climate Change Panel, something like that. They just take the name and form like a community of people working on initiatives to reduce their risk due to flooding and other climate related risks. Mm, and let me conclude with two things. First, thank you. I couldn't find all the pictures here. For instance, I miss Carolina here. I know she's here, but this is not my work. This is team work at the university, working with different people. And don't take me wrong. Uh, this is a great city. I love my city. This is great for visiting. You can look for Medellin at TripAdvisor or things like that. So welcome, and thank you. And we are working to solve this. Thank you.
Great presentation, Juan. Thank you. That's wonderful. Very interesting. Okay, is there any question for Juan? Yes. Jesus, you can unmute yourself and ask your question, please. We can't hear you. Excuse me.
Can you hear me now?
Yes.
Oh, okay.
Yes.
Excellent. So fantastic presentation, Juan. Thank you. And so when you do your hydrologic simulations for different types of urbanization, how are you representing that urbanization in the sort of parameters of these models?
Okay, the results I show you here are like a business as usual scenario. So we keep the parameters of the current urbanization in the new urban area. But in another experiment I didn't include here, we changed these parameters to simulate the effect of expanding the city, but in a different way. I mean, like using sustainable urban drainage systems or nature-based solutions and things like that. And the effect is significant. I mean, how to urbanize is very influences the peak flows importantly. I can comment more, but I want to be short just in case we have another question.
Great. Any other question? I saw one more hands up. You can also ask your question. Yes. George, am I correct?
Yeah, Jorge, it's okay. So,
Yes.
Juan, I wonder what type of hydrological model do you use? I understood that you use the previous climate conditions to simulate what was happening before. Then and what is happening currently now, and then you projected that with new urbanization scenarios and new climate scenario. But I didn't notice. I'm sorry if I missed that. What type of hydrological model were you using, or hydraulics, or both? What type of combination?
Yeah, it's a hydrological model. It's the HLM, the Hill Slope Link model. It was developed by the Iowa University, and they use this model in the Iowa Flood Center, so we use that one. And it's just hydrological, not hydraulical. We have done hydraulic experiments as well, but those results are not included here.
Great. Bernard, you can ask your question. Yes.
Yeah, thank you. Good morning, good evening. Fantastic presentation. Juan, thank you very much. Urban hydrology is something that I also have interest in. A couple of years ago, I've been working on close to a similar work in Nairobi. How are you? How is the communities around the river dealing with disasters, especially flood risk? And has there been past incidences of fatalities, for example, associated with this? And how does the local government try to raise advocacy around this to minimize the catastrophic impacts of such? And also the aspect of solid waste, as cities grow, challenges come in. Has that been also a factor that has influenced the peak floods in the area? Thank you very much.
Yeah, I think I missed the second part of the question, but I will ask the first part. So how are communities and the government dealing with this? That was what I understood. So one very, very important thing here is that the government decided to implement an early warning system called SIATA. So we have many things to produce early warning system. That's good, but not enough, because we in the short time we need the ability to give early warnings to the people, but we have to transform the territory, and in this part we are still working, and there are bottlenecks, as I said. And communities, interestingly, are not just waiting for the government to do something. Some communities are organizing themselves. That's the example I mentioned of the PICC. This is a community saying, okay, we won't wait until the government comes. We want to work with the government, but if they don't come, we will do something in our neighborhood. So they are doing things like rainfall harvesting, planting trees, educating people, teaching people how to react to different events, or having local warning systems based on, yeah, a cell phone. Give me a call if you see the river at this level, things like that. And there's a combinations of things like this in the city, because people in this city is getting more and more concerned about these things, and want to do things. And I'm not sure I get the whole question. There was a second part, but if you want to repeat, or
Yeah, thank you. Yeah, I get the kind of heightened awareness among the public, such that they're taking initial steps just to secure themselves. And the second question was related to the solid waste that sometimes in other cities, in developed countries, becomes a major challenge to drainage facilities. And most flooding that would not necessarily be catastrophic are kind of heightened by the solid waste occupying some storm drains. Could this have been also a situation in the past? Although I saw the river channel depicting a kind of a well-maintained channel without much of the solid waste, for example. Thank you.
yes, solid waste is an issue. and also an excuse because of course it influences, and there's still some people uh, sending solid waste to the rivers, but it's also an excuse because sometimes some politicians used to say that okay, it's because of solid waste, and I used to say okay, that's an influence. It is very important to tell the people not to do that, but that's not the whole story because you have climate change, you have urban expansion, and urban expansion is also your responsibility. So yes, solid waste is an issue.
Thank you. Thank you very much, Juan. Yeah.
Any other question?
I see one in the chat.
Yes, you can go ahead and read and answer it, Juan.
Oh, okay, Karim asked if can we use nature-based solutions to manage the effect of growing urbanization and reduce the risk of flooding? The short answer is yes. We have simulated like the effect of expanding the city in a business as usual scenario and in a different scenario using, for instance, nature-based solutions. Of course, that's a great idea. What we need is to do many things. So there's not a simple recipe or an easy solution. We have to do many things, including, of course, nature-based solutions. I think that has an effect. For instance, my idea of just giving a space to the river at the end is a nature-based solution because rivers need flooding plains. So just give flooding plains to them. The problem is that we have the city here, so we have to be very creative to do that. And it's not easy, but I think it's possible. And climate change is not easy, so I'm okay with possible, although difficult.
Great. Any other question you guys may have?
I have a question,
Yeah,
Sarah.
Josh.
Thanks. Thanks, Juan, for that presentation. It's really interesting, really some great work that I think is, yeah, it fits really well with what we're trying to do in this crosscut. And that's actually one of the questions I wanted to ask you is like you've done a lot of this great work. I think you could really contribute to some of the crosscut stuff, but also at the same time, from your perspective, what do you see as the biggest limitation in modeling that, like getting a group of people across the globe working in the same space that you are relative to like climate, urbanization, and that interaction? What do you think, what do you feel like would be most helpful or most innovative in that sense to like push the science forward in this space?
You mean in our place?
In your place, yeah, like so from your perspective, if you could have a group of people across the world working on one sort of problem that you're facing from like the modeling climate space, what would that be in that sense?
Okay, from the modeling perspective, I think we have to resolve many uncertainties about parameterizations, and since this is a city, we have even uncertainties about the river network because part of the river network is simply hidden, and it's a mystery. Sometimes we don't even know the channels where the water is flowing. We have been working on that too. So we need better parameterizations, we need information, we need data. We have a lot of data, but for instance, a very important uncertainty is about like small catchments because most of the equipment is just near the river, so we have data. But in the upper parts of the basin, it's not easy to have like information there, and the dynamics there can be really different. For instance, how do you relate a peak flow near the river with a peak flow just in a neighborhood up there? And there are no simple rules to do that, and we need those rules to simulate this, and that's a challenge, not only for us, of course, but let me add that that from the modeling perspective, but from another perspective, I think the most challenging thing, and I used to say, okay, we have a lot of information, we have uncertainties, but we know enough to tell the society and the government this is a growing problem, and if we don't do things quickly, we'll face disasters. So we have to move quickly, and it's very hard because they used to think, okay, it's very difficult, there's no money. Yeah, that's the whole story of climate change.
Yeah, no, I think that's right. I specifically asked about the modeling side because that part's easier for me to wrap my head around than like the second part you're talking about with the interaction with people and changing and all that stuff is really difficult. But I think it is important that we think about it because that's actually where things need to change and things need to happen. So I appreciate your response to that. It's really good to have your perspective on sort of those limitations or things that those uncertainties. I think that's true across the world dealing with floods in urban areas, right? It is so difficult to try to get all the catchment stuff right. So yeah, thanks.
Thank you.
Any other question for Juan? So I have a quick question for you, Juan. You mentioned about the early warning system. Could you a little bit elaborate on that, how it works? I can say like, is it like near real time, and how is the interval of warning that it issues during flooding?
Yeah, we have like two things here in
Mhm.
the valley. One is the CIATA. This is the name. This is an acronym in Spanish, but this is an
Yeah.
early warning system. We have a radar more or less here, yeah, in the center of the circle. And this is producing data continuously. So we have continuous data, and this is very important. And we also have a lot of gauges in the river and precipitation gauges as well and things like that. And we used to. Oh, I'm sorry. I just realized that my camera is off. I'm so sorry. Okay.
No problem.
And uh, so we have this system, and this was like a tipping point, a good one for us in the city because we didn't have this, and we have this. I mean, 10 years ago, more or less, and this changed the situation. But we also have community early warning systems. The local authorities have organized and have helped people to organize sometimes around rivers, for instance, and they have like simple systems and like a protocol just for people to be aware in some places. And if you look the river touching this level, make a
Yeah.
call, and they know how to react. And this works. This works. And so it's a combination of technology, science, and people in the territory.
Nice, very interesting. That's great that you have community involvement in the kind of this kind of it's very important community engagement. So make it a lot easier. So it got to be costly too, that kind of sensor, early warning system, the update maintenance, and the labor work. That's great job. I mean, we'd be happy to get some of your data if you guys are okay. I mean, to put in our model. Um, so
Of
we are also
course.
looking at the stormwater infrastructure in the city as well. Uh, and some area, I mean, in the US, because of the security issue, we couldn't get those data set. I don't know how it works with your government. But that would be something that we would be very interested to get those information and put into our model to test and see how it perform here. Very interesting. Yeah.
Yeah, of course we can talk further about that and
Sure.
share data and share Yeah, it would be great to test, for instance, one of your models here, or I don't know. Yeah, we can talk about that
Yeah.
for sure.
Thank you. Very good. Okay, so if there is no more question for Juan, we thank him for his presentation. Thank you, Juan. Great job with this research, and we enjoyed it. Thank you very much. So for our next meeting, just want to let you know that we
Thank
have
you.
Professor Hamid Murad Khani from the University of Alabama in US. Our next speaker, uh, invited the speaker, and then our meeting would be on Friday, April 3rd at 9 o'clock a.m. Eastern US time. So I encourage you guys to attend that talk as well. We will send out the information and the agenda related to April meeting. And again, we appreciate your participation. I put the Google Doc in the chat box, so please add your information regarding your publication, papers, reports related to flooding in your study area, in your region where you are located. And we'd be happy to use those information when we write our final report for GEWEX. All right. Anything we need to add, Josh?
Nope, I think that's good. Thanks again, Juan, and thanks everyone for attending. It's great to see so many people here.
Yeah, that's wonderful. That's wonderful to see a lot of people, particularly from South America, which is the area that we are interested in having more kind of speaker from that areas to understand you guys' problem related to flooding in your region. So please reach out if you are interested to get involved. All right.
Okay, thank you very much. And
Thank you.
I would be very glad to contribute to a report. Just let me
Sure. Yes,
know.
we'll be in
Okay.
touch. Yeah. Thank you,
Okay.
Juan. Thank you
Thank
again.
you.
Thank you,
Thank you.
everyone. Have a great weekend. Bye.
Yeah. Bye bye.
Thank
Thank
you.
you.
Bye.
Bye bye. Yeah.